So as we head towards the last session today, we will have Jordan Plawner from Intel to discuss the AI for business, generative AI for the real world. So over to you, Jordan.
Okay, thank you for inviting me here today. I'll give a good survey of what are the trends in generative AI and sort of where we think this technology is going in the next year or two. And I believe there'll be some time for a Q&A right after. Okay, my name is Jordan Plawner. I'm a Senior Director of Global AI Strategy and Product Management at Intel Corporation, focused mostly on data center and server products related to AI. So what are we going to talk about today? You know, ChatGPT was released in December of 22, and it was really one of these amazing iPhone moments where suddenly all of our friends and neighbors and family actually for the first time could touch viscerally, AI and experiment with it, converse with it. And it really brought AI to the forefront and out of just sort of, technology. And so what we know about these massive, with these kinds of models is that they're very large. They take, months to train, and they're very expensive to build. But paradoxically, the future of generative AI is not actually more of these massive models. In fact, it's going to be thousands of expert nimble models deployed everywhere. Okay, everything from standard general purpose servers to laptops to phones to kind of edge embedded devices. Because AI is mathematically, computationally intensive, right? It's a tremendous amount of math and statistics. We believe that every product that computes must have some kind of, hardware AI acceleration, simply to have the ability to put AI everywhere on every device and do it in a sustainable way. It needs to be based on open source software, because if you want to have AI everywhere, then the software that developers and data scientists and other people use kind of must be open source so people can continuously iterate as new use cases emerge. And finally, there needs to be, industry models and tools and frameworks that are based on top of this open source software to make developers productive. People talk a lot about performance, but the number one thing I hear from my customers is about productivity. And lastly, this vision that I'm explaining here is we need to take AI out of sort of this bespoke, kind of dedicated infrastructure where AI is the application. We must move to a place where AI is part of an application. It's just another function that's part of a general purpose app. So the ultimate vision is that AI is just running on existing enterprise IT infrastructure, standard enterprise networking, storage and data management, and that's portable and multi-cloud. And those are the themes of IT in general in the data center. Everything needs to be, kind of based on IT infrastructure and portable and multi-cloud so that things can be easily orchestrated, secured, and, deliver great performance out of the box. So how do we get to that vision? So as I mentioned at the very beginning, something like ChatGPT, a large generative AI multimodal model, incredibly versatile, that took weeks to train on a data center scale cluster on web scale data, right? It literally trained on all the data on the web that it could get access to. And very quickly, faster than I've ever seen before, we then see developers saying, hey, I took the fundamental technology that underlies things like ChatGPT and Midjourney, which is a generative AI image service, and I was able to fine tune a similar model in a day or less on, say, a Xeon scalable processor or one GPU using my server or just even a workstation on my private data. So how did we go from this, lifetime of change and evolution from December 22 to today? So let's tell that history, of the last year. So ChatGPT was this amazing general multitask model, right? It achieved 100 million users in 2 months, kind of the fastest ramping service ever deployed in our industry. But very, very quickly, companies started releasing these general optimized models, dozens of smaller, models were being released over every few weeks, and many of these were achieving millions of downloads in a matter of days. They come with commercial and non-commercial licenses, and they're upwards of 30 times smaller than the largest models, but yet have similar accuracy. And what we learned from this experience is that smaller models can replicate the accuracy of larger models if trained on carefully sourced data. So where ChatGPT was trained on web scale data and actually had lots of problems with accuracy and hallucination, as we've all read about, it turns out that a much smaller model can replicate or even exceed the accuracy of a larger model if you're carefully sourcing the data. And I think that's a great theme for today, which is about enterprises don't just have one big sort of web scale set of data. They have many, many different data sets across all the different departments and lines of businesses. And when you feed individual, curated data sets into a much smaller model, you actually get state-of-the-art results. Finally, out of these sort of open source generative AI models, we then got an ecosystem of hubs and AI platforms that are now making available literally hundreds of thousands of domain-specific commercial models that can be fine-tuned, and I'll talk about fine-tuning in a moment, on the domain or private data in less than a day for a few $100s. And these are kind of upwards of 300, 400 times smaller, again, with similar accuracy. So if we have something like ChatGPT and we have something like an open source model that someone can download and fine tune with their own private data, does that mean we don't need ChatGPT? So here's a way of thinking about these different services and options that come to market. If you need a product or service that knows about business in general, then something like ChatGPT and these other large language models that are being offered as a service through an API call are great. They're best for generating information from public data, document search, personal note summarization, kind of sentiment analysis on social media content, maybe even generating kind of general purpose marketing documents, things that are repetitive tasks, maybe batch translation as well. But if you need a model or an AI system that knows about your specific business, well, the call to action is you really need to self-manage by downloading and running an open source model in your enterprise infrastructure. This is likely to be offered by an AI platform or a model hub company. And this is best for anything that would give your company a differentiated or competitive advantage in the market. So things that use proprietary data for mission critical apps to automate customer service and satisfaction, things that have to do with reputation, maybe market share gain and cost reduction. So again, know about business and know about your business. Two very, very different paradigms of how these models can be used and applied. So let's kind of do a walk of this journey that we just described to give a little bit more kind of content. So something like ChatGPT and Midjourney, I've named GPT extra large, right? Closed source, multi-model, multitask models, trained on hundreds of billions of parameters and 13 trillion tokens. And then we got these kind of GPT open source models with similar accuracy, greater efficiency because they're smaller, but typically less versatility. You lose versatility when you shrink a model typically. And these models are usually less than 100 billion parameters, sometimes as small as 7 or 10 billion. And they're trained on 1 trillion tokens. And then this is where the enterprise comes in. The enterprise should be looking at models like, say, Llama 2, which is a model that was open sourced by Meta and Azure, and download that model, fine-tune that with the customer's data. And what you get out of fine-tuning a much smaller model is you get explainability. You can figure out why your model might be hallucinating. You might be able to look at bias and trace back where the bias may be coming from. You get timeliness because a small model can be updated more frequently for less money quickly, right? So you just have more control for kind of mission critical applications. And if you think about model size, we often use billions of parameters as a proxy for model size, but you could also think of data set as another proxy for model size. You would never take a multi-hundred billion parameter model and use that to train on megabytes or even gigabytes of data. That makes no sense. The model is not aligned in that case with the data set size. And as I talk to a lot of enterprises, everyone still has siloed and fragmented data. They have data that are for specific businesses, and they really just want to fine tune an expert model just on the data set for that specific task. And so what you end up with in the end are these GPT expert models, economical, environmentally sustainable expert models that can run on servers all the way to smartphones, starting at 10 or 20 billion parameters, and going smaller than that, obviously, when you start talking about putting these models on the phone, right? So you can take a generative AI model or a chat bot model, and you can train it on, say, proprietary legal chat data that a law firm has captured. And now you get that law firm's proprietary, 7 billion chat law model, and so on. One of the things that's a really important metric in generative AI for real-time communication is 100 milliseconds response time, because that is slightly faster than human communication. So if you're at a less than 100 milliseconds latency, then typically you'll have a very kind of smooth conversation with some type of AI-based computer system, either to generate content or to query. So the future is from these dozens of large foundational models like Llama and Falcon. We get tens of thousands of expert models trained on private data and deployed on tens of millions of services and billions of devices. I heard one time someone explain recently that you can think of these types of expert models as the new database for companies, because these expert models are kind of fine-tuned using the private data from the database. And now these models themselves become the kind of proprietary data. They're no longer generic or general purpose models because they've been fine-tuned on the proprietary data. So the model themselves kind of reflects or represents the database. So for those of you who are familiar with AI, there's a kind of end-to-end pipeline that people show, which is, you do data preparation and you train a model from scratch, and then you do kind of create an inference model, right? And so what we see now with generative AI is that the models have gotten so large on the pre-training side that there's a new stage called fine-tuning, and fine-tuning is the new training, right? And Julian Simon, who's the chief of AI evangelist for Hugging Face, he has a quote here that transfer learning or fine-tuning is quickly making training a thing of the past for 99% of organizations, because those 99% of organizations can just choose a model that's already been pre-trained and just focusing on fine-tuning with their data. So thinking a little bit about the kinds of then hardware choices one would make, and this will be my last slide before we make a transition into QA, is you can think about, there are a handful of companies, I talk to them all the time, especially companies in the pharmaceutical space, healthcare space, people with very unique data sets, people who are very concerned about the legal issues with these large scale open source models and want to pre-train a model with themselves, knowing that their data is all in the clear or legally copyrighted and licensed. But so people will need to pre-train large models from scratch. And like as an example, Intel has the Intel Gaudi processor and cluster, and NVIDIA has their NVIDIA GPUs that can service these hundreds of customers who need to pre-train a large model from scratch. And I think increasingly, most companies won't build their own large cluster unless they need to do this training all the time. They'll go into some type of developer cloud or hyperscaler cloud, and they'll just rent the infrastructure for as long as they need to pre-train. And then they'll, kind of give the infrastructure back to the IT pool. And it doesn't really make sense for most customers, especially in the enterprise, to start thinking about building their own massive clusters. And then when you think about on-premise, right, or I should say multi-cloud enterprise IT, which includes on-premise, public cloud, and the edge, there you need to think about your general purpose servers, right? How these tens of thousands of customers can just fine-tune these tens of thousands of expert nimble models in minutes to hours on workstations and multi-node servers. And this might seem paradoxical because we're all hearing about how these models need to be trained on massive clusters. But actually, we have transitioned actually from that first kind of understanding to the adoption of techniques around really efficient fine-tuning, typically in less than a day, right? So we're able to distill the technology in these massive models down to much smaller models and then get the accuracy by using the customer-specific data. And then finally, if you want AI everywhere, if you want AI infused into every application in the data center and on the edge and on laptops, right? Now we must be able to run the AI models co-located on the same servers that are running the application. So, we expect that inference deployment, as long as you can meet the customer's SLA of less than 100 milliseconds for the token latency, we expect that the, inference deployment really just kind of scale out on, Intel CPUs, AMD CPUs. In some cases, people will still need to use GPUs for a lot of media and visual intensive applications. And then you can even go all the way down to like laptops and Intel Core, which also has, a kind of integrated AI acceleration on the CPU so that you can get really efficient AI on each processor. So I think the key takeaway is, the call to action is, look at some of the things that are in this slide around Hugging Face, around fine-tuning techniques, and either you or your data science teams that you work with, that this is the direction they should be going in. There's a bit of a reaction right now to everyone wanting to have their own clusters. But in fact, the technology foundation is already there for customers to just kind of distill it down to a much more manageable kind of container and package and run this on premise or in their cloud on their general purpose infrastructure. So I think that's where I'm going to stop, and I'm happy to take any questions.
Thank you, Jordan. So we actually have a question here. Which industries are you seeing adopt Gen AI technologies the fastest?
The fastest. Yeah, that's a great question. So, Gen AI, right, in terms of this popular current conception, kind of kicked off at the very beginning of the year. So what I have observed is that everyone wants to be doing something in this space. So everyone is kind of setting up a chatbot because that seems to be the easiest way to get started. So chatbots can be used in almost every industry, both for external customers, but also to help internal employees find information faster. So it's not really pertaining to any one industry. I think if I look outside of just generative AI specifically, and just where there's a lot of adoption of NLP models like BERT Large and adoption of vision models, the areas where we see a lot of adoption is healthcare, which is a very kind of hospitals, which is a very kind of image and intense environment, to help in diagnosis and treatment. Manufacturing, a lot of people are doing really interesting things around defect detection and other kinds of tracking on the manufacturing line. Retail, right? People are using cameras in store to either do automated checkout, to do theft detection, to monitor kind of people movement, to figure out how to optimize their shelf space. So I think and then financial services, I think banks are investing a lot in AI, automated customer service, for fraud detection, for like loan recommendations. So those are just a few. I would say in general, AI is being adopted everywhere, but those are a few that come to mind as the fastest adopters.
Thanks. So we actually have a comment here in the chat is about like next phase is over-the-air model deployment with massive model distribution. So what do you think, Jordan?
Can you repeat the question?
So the next phase is over-the-air model deployment with massive model distribution. Do you think that is a trend for the next phase?
Over-the-air model distribution, is that what you said?
Over-the-air model deployment. Yeah.
Yeah, I don't know what that means. I'm sorry. Maybe someone could clarify the question, or maybe I don't know if people can go off mute and ask it, but I'm not. Yeah, I'm sorry. I'm not clear on that question.
It's fine. So, excuse me, I cannot pronounce your name. If you can elaborate on the question, it will be great for Jordan to comment on. But the next question is about, do you see many Intel customers running generative AI workloads across cloud providers or on-prem environments like hybrid cloud, multi-cloud, or they are mostly in a single cloud environment?
So everyone's sort of multi-cloud, but when they run, I would say in AI, when they run a specific application, they typically run it either on-premise or in the cloud because they're really running it where their data resides. And so typically we see for these very task-specific models, the data just resides in it's either in the hospital or it's in the cloud, and not typically both in live in production. So the answer is they're doing both, but not doing both simultaneously in the same model. And like lots of other things in IT, it really depends on where their data resides. One also interesting split is that people have data centers, and still even though they might be using cloud for their expansion, a lot of their data analytics is still done on premise. A lot of their most confidential data is still kept on premise. So a lot of the training or fine tuning will be done on premise by the data scientists locally, sometimes just with a laptop or a workstation. So local is really valued for data science. Not always, but largely. And then, of course, when you want to then integrate the inference model into an application, well, then now that depends on where the application resides, where the data is being generated, because inferencing is typically inferencing on streaming data of some kind. So then inferencing will happen typically wherever the application lives. It might be on premise, but it might be, in different geographical zones around the world where the application lives. So yeah, so I guess one way of, a lot of the questions about AI, this is a great example, is, well, how would AI be deployed? And I don't mean to be flippant, but a lot of times the answer is exactly how your IT is deployed, right? You should not have to change your your IT to meet AI. AI should be able to go everywhere, your IT systems reside and your applications reside. So
Thank you, Jordan. So any other questions from the chat? Yeah, I think that's it for the questions Q&A. Okay, here, another question. What
yeah.
kind of embedded systems do you see this being used in?
So we define embedded systems at Intel, at least, as these sort of edge devices, right? Not like a standard server or a standard client, but some type, an ATM machine or sometime a security monitoring system in a baseball stadium. So if you mean that as an embedded device, today, to be very clear, generative AI is not really proliferating on the edge, because if you think about it, which is where embedded devices are typically on what we call the Internet of Things or the edge. Generative AI, as amazing those models are, it's there to generate data and generate content from the inputs and from the query. And typically embedded devices on the edge don't generate data. They're not typically real-time, devices that people interact with. So while generative AI is amazing, it's very costly. The models are very large and expensive. And if you're not needing the generative AI capabilities, then you should be using an older, like circa 2022, highly optimized vision model. So like YOLO 8, as an example, is a model that's still highly, highly valued and adopted. And while we might say, well, YOLO 8 is a toy model, but it gets the job done. It's the right tool for the right job. So while we're in this, and it's very exciting for me, while we have this sort of generative AI moment, we must remember that with these incredibly versatile models come, they're bigger, they're more expensive. And if you don't need the value of those models, then go pick an older model that really gets the task done, and that uses far less memory, less power. Embedded devices are often battery operated, and they're often air cooled in a closet. So it's very, very important to not over subscribe, what you're trying to do, and fit the right model for the right use case. So I think it'll be a little bit of a while before generative AI use cases on the edge kind of mature.
Sounds great. We have a question here about what is Intel working on the AI side that you are most excited about?
Oh, that's a great question. What I am most excited about is something that I mentioned in the very beginning, which is, we have great, AI software teams developing the algorithms and improving the workflows for different generative AI models, optimizing for lower latency and very efficient, data movement. But what I'm most excited about is sort of where Intel's sort of legacy is, which is helping customers scale AI, in this case, AI, but it could be any workload on people's customers' enterprise IT. So it might surprise some people here, but from my standpoint, if I want to help Intel scale AI, I think about companies like Red Hat, VMware, and other enterprise ISVs, Oracle, SAP. And I think about these companies that help manage and move data and create data platforms and create the infrastructure like the vSphere, VMware infrastructure. And my thing I'm most excited about is working with them to make it really easy for a data scientist or an applications engineer to just request a bunch of nodes to do fine tuning, launch a fine tuning job for a day, and then give those nodes back to the IT pool so those nodes can be used for something else the next day, right? So I think in the end, like this kind of running AI on top of a virtualized enterprise infrastructure is like the thing I'm most excited about. And when I talk to customers, they like, yeah, that's like where we need to get to. Like we're investing a lot of money in our labs to buy like dedicated AI equipment to kind of train models. But everyone really wants to get to this point where AI is just another workload, right? Just like AI is just another analytics workload, as you're hearing about today, and we just want AI to kind of take its place in IT and not be this kind of orphan off to the side, in a lab. So that's what I'm most excited about. And there'll be some announcements in the next few weeks from Intel and VMware about the work we're doing to make this happen.
Thank you so much, Jordan. Thanks for your insights and thanks for the question in the chat.